Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2018. This question was from the topic of resonance column method from sound waves, and this was slightly controversial in nature because of one of the options. So let's see what we are talking about. First, let's see the data of the question. There's a tuning fork of frequency 500 Hz, which is used to create which is used to create waves in a resonance column tube. The length of the air column is varied by changing the water as the normal process is, and it is said that when the length of the air column is 50.7 and 83.9, so successive resonances are observed. Two successive resonances are observed. Okay. So using this data, we have to find the speed of the sound, the end correction, wavelength, and all these things. Okay. So now if you look at the data, let's talk about 83.9. So this is the length of the air column. So if you try to recollect from the theory, so suppose below this there is water. Okay, so this is below this there is water, and this is the air column. So the open end of the tube is here. You can see, but the antinode, if you talk about displacement antinode, so it is formed slightly outside the tube. So it is this is the somewhat situation. Okay, now as of now we do not know. I have just drawn this illustrative figure. There can be more number of loops or less number of loops. Right now we do not know how many loops will be there. You can have 3, 4, 5, or 1 or 0, whatever. So basically we will see what is the scenario. So let's say so length of air column is this, like from the open end of the tube till the point where the water surface lies. Okay, so this, let us say, is 83.9. now, if you increase the water level, so length of the air column will decrease, and we can say that 50.7 is the next resonance. Okay, so basically it will be actually opposite. First, we will get the resonance at 50.7 and then 83.9. So anyway, the difference in these two lengths will be lambda by 2, because we know that the moment the length will differ by lambda by 2, we will get a resonance, and hence we can say that 83.9 minus 50.7 must have been equals to lambda by 2. So if you take the difference, you get 33.2, which is lambda by 2, which means lambda is equals to 66.4 centimeters. Okay. Now velocity of the wave can be simply found out by using f into lambda. F is 500 and this is 0.664 meters. So this can be written as 1000 into 0.332, which is nothing but 332, and hence speed of sound comes out to be 332 meter per second. So this makes option A correct. Now this was the controversial option B. The end correction in this experiment is 0.9. In reality, now let's try to find the value. Let's try to see what is the value of lambda by 4. Okay, so if lambda by 2 is 33.2, then lambda by 4 will be equals to 33.2 divided by 2, which is nothing but 16.6 centimeters. This is lambda by 4. Okay, we will shortly see why did I find the value of lambda by 4. Now if you see carefully, if you further decrease the value of lambda by 2 from this 50.7, so let's further decrease the value of lambda by 2 from 50.7. So 50.7 minus lambda by 2. Okay, so this becomes how much? 50.7 minus 33.2, so this will become 17.5. Okay, so the till the time we are able to deduct lambda by 2, till that time we can say that like the resonance must have been of the higher value. So what I'm trying to say is that, see, in the fundamental mode, this will be the scenario, like water surface will be till here in the fundamental mode, and this will be the scenario. So basically we can say the length of the air column will be this will be water surface, and this will be length of the air column. Okay, so if you try to further decrease the value of lambda by 4 from lambda by 2 from this, so it will not be possible. So that means this is the fundamental case. That means the length of the air column in this case is 17.5 centimeters. This is the length of the air column when fundamental mode happens. Because suppose if this would have been the scenario and this was the air column length, then we would have been able to decrease lambda by 2 from here in this picture. You can see that if the length of the air column is more than lambda by 2, then we would be able to decrease the value of lambda by 2 from the length of the air column. But the moment length of the air column becomes 17.5, we will not be able to decrease 33.2 from this. Hence, we can say that this must have been the fundamental mode. I hope you are clear with what I said. So that means this is the length of the air column, 17.5. Okay. Now, lambda by 4 must be equals to 17.5 plus end correction. This value is called as end correction. What is end correction? End correction is the the displacement antinode is formed slightly above the open end of the tube. This is the open end of the tube, and this is the displacement antinode. So it is formed slightly above the uh, open end of the tube. So we can say lambda by 4 must have been is equals to length of the air column in fundamental mode plus E. So basically we can say that 17.5 plus E. Now this creates a problem because lambda by 4, as you can see, is 16.6, is 17.5 plus E, which makes E is equals to minus 0.9 centimeters, and correction is coming out to be negative. So basically, which should not be the case, because in all the standard books, in all the theory that we have studied or you must have been taught, we realize that end correction should always be positive. That means the uh, open end of this must always be outside. So this is what created sort of controversy and confusion in some of the students' mind, and they did not select zero point 0.9 as the correct option. But IT had taken this as the correct option. Probably, in my opinion, they wanted the magnitude, or they wanted the they were talking about a hypothetical case maybe, because frankly speaking, I have never seen a case wherein the displacement antinode is formed uh, inside the open end of the tube. Okay, practically speaking, in my opinion, this does not happen. Okay, anyway, so IT had taken this as the correct option, but in my opinion, this should not have been the correct answer. That is what I believe. Okay, so let's go back to the next option, the wavelength of the sound, which we have already found out, 66.4. So this is correct. The resonance at 50.7 corresponds to the fundamental harmonic, which is wrong because we realized that 50.7 was not fundamental harmonic. It was the first overtone or third harmonic, right? The fundamental harmonic will be at 17.5 centimeters. So in my opinion, option A and option C should be the correct answer. However, IT had taken A, B, C as the correct answer. So that's it from my side. Thank you.